In the second half of section 2.4, we're going to work on the order of operations. Let's quickly review what they are and actually have a little instruction as we go through them. The first thing we look for in the order of operations is grouping symbols. I want you to remember that grouping symbols can be anything from fraction bars, where you have to solve what's on top and what's on the bottom separately before you can simplify. We also have parentheses, and outside of that we have brackets. Those are all things we look for as far as grouping symbols. The second thing we look for is exponents. Now we do need to learn a little bit in this section. Let's just quickly remind ourselves, when we're solving exponents, you take the base number, like this 2, and the exponent tells you how many times to multiply the base. So if you have 2 to the third power or 2 cubed, that means it's 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. So 2 to the third power is 8. Now, we are going to start seeing fractions when we do this. So let's take a look at what you do when you have a fraction that's to the third power or a fraction that's cubed. So if I'm looking at 2/3, let's say I'm looking at negative 2/3. And I have that cubed. What you need to realize is that that cubed goes with both the numerator and the denominator. So what you can do is you can rewrite it as negative 2 to the third, because remember the negative can be with either one, over 3 to the third. So it goes with both numbers. So negative 2 to the third is negative 2 times negative 2 times negative 2 over 3 to the third is 3 times 3 times 3. So negative 2 times negative 2 is positive 4. Positive 4 times negative 2 is negative 8. So my numerator is going to have negative 8. And my denominator is 3 times 3 is 9. 9 times 3 is 27. So it's negative 8 over 27. So what you're actually doing is you are taking the exponent to both the numerator and the denominator. And again, if the fraction is negative, just put that fraction or that negative with the numerator so you can solve the problem appropriately. In our last two steps, we look through the problem and do all of our multiplication and division from left to right, and then all of our addition and subtraction from left to right. So what we're going to do now is just a few examples. I want you to try the example before I go through it in the video, just to see if you're getting them right beforehand. Okay, take a second to write this problem down, and then pause the video and try it on your own. Okay, welcome back. So the first thing we look for is grouping symbols. I don't see any grouping symbols in this problem. Now, some people might think those parentheses are grouping symbols, but they're just separating the problem from the plus or the fraction from the plus. There's nothing inside there that you need to solve. The second thing we look for is exponents, and I do see that I have an exponent right here that I need to solve. So I'm going to start with that. I know that 3/4 squared is 3 squared over 4 squared. So 3 times 3 is 9, and 4 times 4 is 16. So that's 9/16. And I'm going to rewrite the rest of the problem around what I just solved. Okay, I look for any more exponents. I don't have any. So the next thing I look for is multiplication or division from left to right. I see that I have this multiplication here. I have negative 1/6 times 1/2. I'm going to take a second and move that negative sign so it's with my numerator. And since they're already both in A over B form, I can check my diagonals here. 1 and 6, nothing can be simplified. Negative 1 and 2, nothing can be simplified. 1 and 6, my vertical, nothing can be simplified. And 1 and 2, nothing can be simplified. So because of that, I'm just going to multiply those across. Negative 1 times 1 is negative 1 over 6 times 2 is 12. So I have negative 1/12 plus 9/16 minus 1 5/6. I have no multiplication and division left, so I'm going to go addition and subtraction from left to right. Now, honestly, because now we know integers, we could change the subtraction to an addition problem. I could change it to addition and take the opposite, and then I'm dealing with an entire addition problem, and you can add in any order that you want. But because we're following the order, let's go left to right. I am going to find a common denominator for all of them. So I know that I need to change this 1 5/6 to 6 times 1 is 6, plus 5 is 11. So what I'm really minusing is 11/6, negative or minusing 11/6. So I have 12, 16, and 6. 6 and 12 don't go into 16. 2 16s is 32. They don't. 3 16s is 48. All of those numbers go into 48. So I'm going to change my denominators to 48. 48. And 48. 12 times 4 is 48. So I'm going to multiply that by 4 over 4. I have negative 4 in my numerator. 6 times 3. So I'm going to multiply that by 3 over 3. I have 27 in my numerator. 6 times 8. So I'm going to multiply that by 8 over 8. And I have negative 88. Or actually just 88. I'm sorry. Because I'm writing that as a minus. 88 in my numerator. I'm going to go left to right, so I'm going to start by adding negative 4 48ths plus 27 48ths. Negative 4 plus 27. Adding numbers with different signs, I subtract. So I'm looking at 23, and it's a positive 23 over 48, because you have more positives than negatives, minus 88 over 48. And now because I am subtracting a bigger number from a smaller, I do need to change this to addition and take the opposite. And what I'm really solving is 23 plus negative 88. 23 plus negative 88, I'm adding numbers with different signs, so I'm going to subtract. I get 63, and it's negative because 88 is bigger, over 48. I know that 48 goes into 63 one time. Take away that 48, I have 17 left over. I'm going to catch my mistake this time. I have 15 left over out of the 48, and I know that that is negative. Now I should always check if you can simplify. We check our 2s, our 3s, our 5s, and I actually know that 3 goes into both of these numbers. So I am left with a mistake. Darn it. So let's go back here real quick. This isn't 63. This is 65. And this was 17. So there is no simplifying. And I do make a lot of mistakes. I am so sorry, you guys. So negative 1 and 17/48, and that cannot be simplified. Hopefully you caught that mistake because yours was right in the first place. Let's do another one. Now you're going to notice that I have this next example written 2 times because there's something I want to show you that might make things quicker for you in your math. Try the problem out and then I'll go through the 2 separately. Okay, let's start with the left side. If I'm solving this problem, I don't have any grouping symbols. Again, I know it looks like it, but this one right here is actually showing multiplication. You're multiplying 3/4 times -2 1/3. And the other one is just showing the fraction that you are squaring. So then I look for exponents. I see that I have -3/4 squared. I remember that -3/4 squared, I'm taking that squared and putting it with both numbers. So it's actually -3 times -3 on the top and 4 times 4 on the bottom. I know that a negative times a negative is a positive, so it's really 9/16. I'm going to say that's minus 3/4, and then I'm going to change this right away. 3 times 2 is 6, plus 1 is 7, and I'm going to say it's times -7/6. Not 6, thirds. Sorry about that. Boy, I make a lot of mistakes. Okay. So when I'm looking here, I'm looking at what I'm multiplying because multiplication is next. So I have to look at this part of the problem. I have in this diagonal, and if it helps you out, you can put a times sign in the middle. But in this diagonal, I see that I have a 3 and a 3 that can simplify to a 1 and a 1. 7 and 4 do not simplify. 1 and 4 do not simplify. And 7 and 1 do not simplify. So now when I multiply across, I have 1 times -7 and 4 times 1. So I'm looking at 9/16 minus, and again, it's -1 and 1 times -7, so it's -7 over 4 times 1 is 4. So I have 9/16 minus -7/4. I'm going to change my common denominator to 16 for both of them. So that means I'm multiplying this by 4 over 4. -7 times 4 is -28. And my first fraction didn't change. So what I'm really solving here is 9 minus -28 because it's all over 16. So minus a negative, I change it to addition, and I take the opposite, and it's actually 9 plus 28, which is 37/16. And when I change that, it's positive because I added 2 positives. The 16 goes into 27 2 whole times. That's 32. So there's 5 left over out of 16. And that is my final answer. Now, where can I do that differently? The first part doesn't change when you look at the second one. That -3/4 squared is still going to be 9/16. But what I'm going to do here before I actually do the multiplication is I'm not going to deal with any minuses. So I'm going to take 9/16, and instead of -3/4, I'm going to change it to plus -3/4 times, and then -2 1/3 becomes -7/3. So I don't have that minus anymore. I already changed my minus to addition and took the opposite. So when I'm multiplying here, I still have to simplify my diagonals. These two cancel out, right? 3 goes into negative 3, negative 1 time. 3 goes into 3 1 time. And all of the other simplifying didn't work. When I take negative 1 times negative 7, I now get 7. And 4 times 1, I now get 4. And it's positive already. So if you compare the two sides, what I'm looking at here, when you look at these two things, they're basically the exact same thing. Because if you look at the left side, minus a negative is plus a positive, you end up having the same exact problem. You're just doing it sooner by changing the minus to addition and taking the opposite right away, and just working with the negative number. So again, I still have my common denominator of 16. This stays. This I'm going to multiply by 4 over 4 plus 28/16. I add those two numbers, I get 37/16, which changes to 2 and 5/16. So you see, same exact answer, it's just you dealt with that minus and changing it to addition and taking the opposite right away instead of at the end. Okay, I want to do one more example with decimals just to make sure we've got that down, and then you'll be ready to get to work. Okay, try this one out. All right, so when we talk about grouping symbols, we need to understand that absolute value symbols are actually grouping symbols as well. So when we're looking at this is the first thing we're going to simplify, and we're going to rewrite the problem. So it says negative 2.1 divided by 14 hundredths minus 1 5/10 cubed. There's no more grouping symbols, so I'm searching for exponents now, and I do have this exponent. I have 1.5 cubed. So that means I'm going to be taking 1.5 times 1.5 times 1.5. Now I need you to think about this because we should be able to do this pretty quick. If I have 1.5 times 1.5, I am taking 15 times 15. It is my opinion that you should have the squared numbers up through 15 memorized because it'll make your lives easier. The squared numbers, the perfect squares, are 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. So in my mind, you should know what 15 times 15 is. 15 times 15 is 225. I shouldn't have to do the long multiplication. So I can do 225 because I know that answer. I see that there's two numbers after the decimal. So I go 2 over and it's 2.25. Now the next one I'm going to have to do. I'm going to have to do 2.25. Remember, I've done these two now because I did both of them. Times 1.5. Don't have to line up the decimals. 5 times 5 is 25. Carry the 2. 5 times 2 is 10, plus 2 is 12. Carry the 1. 5 times 2 is 10, plus 1 is 11. I know that multiplying by 1 is just the numbers. So I am looking at 5, 7, 3, 3, and I see that there are 3 numbers after the decimal, so I'm going to go 3 spaces over. So when I rewrite this problem, I have negative 2 and 1/10 divided by 14 hundredths minus 3 and 375 thousandths. Order of operations tells me now I have to look for multiplication and division from left to right. So I'm going to do the negative 2.1 divided by 14 hundredths. So I'm going to keep showing my work because that's what I'm supposed to do. I have 2.1 divided by 14 hundredths. I know that I have to go 2 spaces over, so I'm going to go 2 spaces over. I'm going to move my decimal straight up in my answer. It's going to be a 0. 14 doesn't go into 2. 14 goes into 21 one time. That's 14. Subtract, I get 7. Bring down the 0. 14 goes into 75 times. That's 70. So, negative 2 1/10 minus 14 hundredths is negative 15. Now, that's a big mistake. People do all that work and then they forget that the signs were different. This one's positive. There's nothing there. So, since they're different, you have to have a negative answer. So then minus 3 375 thousandths. And because it's subtraction, I'm going to change it to addition and take the opposite. And I have negative 15 plus 3 375 hundredths. And I'm going to show the work to the left for this. I'm adding numbers with the same sign. So I add, I have 15 plus 3.375. You have to line up your decimals when you add. 5, 7, 3. Decimal goes straight down. I get 18 375 thousandths. And because I was adding 2 negatives, my answer is negative. All right. So you're going to try this on your own now. Good luck, and ask questions if you have them.